Hi everyone, thanks for coming to this talk. Today I'll tell you everything you need to know about storage, or kinda, because storage is actually a huge area of APIs on Android, so we won't be able to cover all of them. But as you already sit in, it's already too late. You're trapped. So let's start. My name is Yacine Rezgui. I'm a developer relation engineers at Google working on privacy, and storage takes maybe way too much of my time. But at least you got someone who works on that. We'll have normally some time for questions afterwards, so feel free to ask them. If we don't have time or your question may take way too much time, I will be outside of the room after the talk, and I should be kind of visible with this Android t-shirt afterwards. So feel free to ping me offline or online on Twitter. I'll be happy to answer you anyway, at any time. So today we'll have a look a bit on what's the storage architecture on Android, how it has been a bit modified across versions, and why you should care about that. Scope storage, I think everyone had some fun time with it. So we'll deep dive into it. We'll talk about how to add files on the different types of storages and the different APIs you should use for that. We'll have a look at the storage access framework, the photo picker, which we've added in Android 13. I'll tell you more about it. And finally, how we see the future of storage. So, storage architecture on Android is a bit specific because, well, Android is a bit old. Not old on the human scale, but in terms of version, we've been already through a lot, and we're already on the 13th version now. And initially, the way it was architectured will be like you just have your device, whether it's a phone, a tablet, a TV, or even a Wear watch. And whenever you install an app, you have what we call the app storage. So anything here for your app, you can add files. Wait. Doesn't look great, right? Is it bad there as well? Oh, sorry. I don't think it's from me. Is it?
Yeah, we'll fix it.
Oh, okay.
In a minute.
Let's wait. Yeah, actually, the title won't change that much for the next slides. You're right. So whenever you install an app, you have what we call the app storage. So any files you add there, you don't need any permission for that. So whether you save a config file, something that's really specific for your app, no permission. And that's really important because I know still a lot of apps ask for the storage permission even though they don't need it. So we have what we call the internal storage. That storage is completely invisible for any other app. So it's really private for you. You can put whatever you want there. It's fully private. That's why there is this nice monkey hiding his eyes. And anything you put there is probably the most performant storage you have. So let's say you have, I don't know, a device with a memory card. That's the internal storage will always be on what we call the flash storage, the SSD of the device. So it's always the fastest, most available, and less error-prone type of storage. While SD cards, while they're super convenient, we can just pull them out, change them whenever we want, you will have way more errors whenever you try to write a file. It's not always, fortunately, but the internal storage is probably the safest, most private, and most performant area for you to save files. And that's where you will put any databases, for example, with Jetpack Room or similar libraries, or any configuration file like your data store. After that, we have what we call the external app storage. And the difference there is historically that type of storage will be sitting, oh my bad. That type of storage will be sitting on a memory card, and I will deep dive into it before, but I don't know if you remember the Nexus one, rest in peace, long time no see. On that device, you had a really, really small amount of internal storage. Remember all the tricks you were trying to play to try to move the app to another type of storage? That's where the external storage made sense, because most of the time it would sit on the memory card. But the problem of that is any files you put there could be readable and writable by other apps that have read or write external storage. So you should put anything there that's not too private, whether it's thumbnail of, I don't know, a fancy video that you're watching on that app, or maybe just some assets that maybe your game or your app needs to save there. But again, remember to not keep anything private on the app's external storage. After that, there is the shared storage, which is what you see on the file manager. For example, on Pixel is files by Google. Whenever you navigate, that's what we call the shared storage. Or if you plug your device to a computer, that's what you will see there. And inside, normally you have all your camera pictures, all your camera videos, all your music that you may have transferred in, and maybe documents, maybe an invoice, a bill you've downloaded from online. Everything will be there. So what's the difference? In short, the app storage, that's private for you, normally, except the external storage on legacy devices, and you do not need any permission. So if you don't add any files to the shared storage, any files that are public to the user, please stop requesting storage permissions. On the shared storage, you had to ask for the right permissions, which includes read external storage or write external storage up to Android 9. I will explain a bit more what we did with scope storage, but in short, you should just always be conscious of the storage permission you're asking. You can do it, but in short, whenever you just open an app, we haven't been that friends for that long, and you ask me straight away permission, it's not going to go well. And the shared storage is indexed by MediaStore. If you don't know what's MediaStore, it's a content provider, so it's kind of just a database that indexes all the files that you can find there. And you can query it, so you can say, give me all the files that have a MIME type PDF, give me all the files that are GIF images, give me all the files that are bigger than 5 megabytes on all the shared storage. So rather than you going through every single folder, trying to sneak in and trying to find files, MediaStore is the most efficient way for you to find files on the shared storage. So remember when I told you before on legacy devices, we had the external storage, the internal storage. Well, let's imagine a Google Pixel. We don't have memory cards on them because the primary volume is big enough, so we don't need to have an SD card. And that was a choice anyway by the team who made the Pixel. So you can see those small icons where all those storages are just on the device. So there is no specific difference on where you will put. So always try to prefer internal storage if it's private, shared storage if it's not. On an old device, the app's external storage or the shared storage may be on a memory card. So let's imagine you save a file there. If the user removes the memory card, or if it put the device on the computer, it plugs it to try to add files, those storages might not be available. So always double check if they're removable. There is a property, I think, on Storage Manager for that. And there is part of the file API, there is file available or not, to check if the file is there or not. Otherwise, you will literally just have an exception when you're trying to access on reading or writing that file. And that was for all devices. But we still have the Android Go devices on emerging markets where, let's say, the primary volume is still small and SD cards are still a big business for them. So rather than just looking for the primary volume and saying, sorry, I can't save that movie you were looking for, still have a look at the other type of storage you may have on that device. It's extremely frustrating for those users because they're known as not having a lot of storage on their device. And if on top of that, they bought that 32 gigabyte memory card, try to plug it, and your app says, sorry, I don't see it and I don't work, it will just be frustrating for them, which means they will probably not use your application afterwards. The other area you have to think of is anything within your app storage, when you uninstall your app, will be removed. So you don't have to clean that, obviously. The system will do it for you. But if you want to keep a file for the user, let's say you took a camera picture, you will put that on the shared storage. With scope storage, we will go more in details after that, you don't have a wide access to the storage on the shared storage to add files, which was the solution most apps did before. So like putting a backup file or export file. What you can do instead is we have fragile user data flag on the application tag in your manifest. And if you enable it, when your app is uninstalled, Android will tell the user, do you want to keep the app's data? And literally what we will do is we will clear your cache, but we will keep your app's internal storage and your app's external storage in a safe spot. And when you reinstall the app, those files will be transferred automatically for you. So again, rather than trying to spam or trying to find a way or just saying, sorry, you will lose all your data, you can just, I'm really bad with that, I'm sorry. You can just use that property flag in your manifest, and the user, if he or she wants, will be able to keep the data or not. So let's go into scope storage. I know a lot of you had fun with it. In a way, it's job security also. But what was the problem on storage up to Android 9? So every app, whenever they had read or write external storage, they just have access to all the other apps external storage that I mentioned before, but also the shared storage. Whether it's a simple social app game, whether it can be a financial app, a government app, all type of files, all type of apps maybe, sorry. Whenever they ask the permission, they just have wide access. Not comfortable. The other part is, given that they just had a wide access also in writing when they ask that permission, I don't know if you remember those old phones where you will have at the root of your storage, when you plug it on a computer, that app folder, that app folder, that app folder. And you will have literally 200 folders like that, in the same way where, you know, on a Windows, you may have a C colon, and you have a lot of folders there. It's just like, why did you mess up my storage? Who gave you the right to do that? So that's what we try to fix with scope storage. On Android 10, we first removed the need to request permission whenever you want to add files. So let's say you just want to add a document, like a PDF, an HTML file, a picture, a video, a music. You don't have to request permission, because we consider you're just adding a file, that's okay. But if you want to modify other files, you have to request the permission. The second part, you can't put files wherever you want. You have to put it in the downloads folder or the image folder, video folder, so you have to not spam a bit everywhere. And the other part is, whenever you ask for read external storage, you only have access to media files. Because we consider, in a way, mobile phones are kind of an extension of ourselves nowadays. While the computer was kind of that box that stays at home. Well, developers were a bit different because that's part of our body as well. But for most folks, it's just a device separately. But the phone, we have it all the time. So we may have our bills, we may have a copy of our passport that we took it because we have to sign up somewhere with it. So we consider media files being the most common use case of files on mobiles, and we still give access for apps that wants to have access to it. But PDF, no one should have access easily to your bills, your bank statements. That's why we made that separation. So remember that schema we saw earlier? So what happened is, on the shared storage, where we had all those types of files there, now we separate them into having media files. So when you ask read external storage, you only have access to this type of files. And if you want to access to documents, so text files, CSVs, PDFs, etc., you have to get through the document picker. The document picker is the storage access framework. We'll deep dive into it, don't worry. So that's the main separation we brought. You don't have to ask permission if you just add files. And again, remember that if you're just trying to export an invoice, if you're just adding files because, I don't know, you made a funny pictures, you don't have to ask permissions. So I know it's some legacy code, you don't want to touch it, your PM probably don't want to do stuff because you're not adding features. But remember that whenever you're asking permissions, you're asking the user to trust you. And if you keep asking more and more permission and that trust is not established, the user will just refuse it. So yes, maybe he will not access that feature, but maybe he will just go to another app that doesn't ask that permission. So keep in mind that it's not user-friendly, it's also business-friendly to be conscious of privacy. The other part we also did is whenever you're trying to modify a file you didn't create on the shared storage. So let's say you add a PDF file, an image file, that's fair. You added it, there is no problem there. But if you want to modify another image created by another app, let's say maybe your own camera, your device camera, you have to ask the user explicit consent. So there is like a specific API that come up that shows kind of a dialogue where we see the file and say, do you want to grant access to that file? Or I think it's, do you want to edit that file? And only after that you will be able to edit that file. Otherwise, literally, you're just going to have an exception when you're trying to modify the file. And the other part is you need to add the access media location permission if you want to access to the geolocation metadata of the images and videos. Because a lot of apps, no, maybe not a lot, let's not parabolize here, but when you had access to the media files, you could access literally to where that person went. Even without looking into the content of the files, you could just look at the geolocation metadata. And now, to be able to do that, you need to ask that specific permission. So for users, great. For developers, a bit more work, but again, job security. So that was Android 10. Android 11, we made even more improvements. So when you wanted to have access to the shared storage, you had to only use Media Store and URIs. If you're not familiar with that, I think it's just a different way to see file paths, but all the java.io API you are used to, so the file class and things similar to that, you couldn't access to those files. You had to use URI, so you had to open an input stream or an output stream through the content resolver. And now with Android 11, we've emulated a file system on top of that, so you can still use the your usual APIs on the shared storage without any change there. The only thing, specifically for Android 10, if you can't make that conversion because, well, URIs is still not practical for you, you can use request legacy external storage flag on your manifest. So if you add that flag, Android 10 is still acting like Android 9. And from Android 11 onwards, you can just use that Fuse API. When you want to ask for the explicit consent, you will have literally a dialog for every file. When you're editing a lot of files, it's not practical. So we've added a way to do bulk edits with write requests. And lastly, we know that there is some file managers. Like, it doesn't have to be only the device default file manager. You may want to have your own one, or you may have a backup and restore app, something like that. So for that, we've added the manage external storage permission. They have a wide access to the shared storage. The only difference is it's tied to a Google Play policy. So it's not a permission we're expecting everyone to use. You have to have your core use case that's related directly to that. It's not just because you don't want to use our newer APIs. The external storage, the app's external storage is now fully private. So from Android 11 onwards, no one can look and touch your app's external storage. We've added features. If you want to mark a file as favorite, so there is an API for that, and what it will do is when you open your default gallery, you will have an album or like a collection named favorite, and all the files you tag as favorite will be seen there. We have also the trashed. So let's say you want to delete a file, but maybe the user want to revert that decision, like on desktop. You can do that. So you mark a file as trash. It won't be accessible by default, but the system will delete them only after 30 days. But all the default file managers on devices will have a kind of trash collection where they can recover them if they want. And lastly is pending. So let's say you're downloading really big files and you don't want them to be visible let's say you are going on your collection, and sometimes you may see like empty files or transparent thumbnails of files, because those files are still being downloaded, but when other apps look at them, they're like, well, that file is empty. I don't understand. So rather than making them visible for other apps, you can use the isPending flag, which will make the system hide them until you're ready. And after that, you can flag them again as, well, ready, so removing the isPending flag, and things will just run smoothly for other apps. And lastly, that will be really important regarding a section that I'm talking after on the photo picker, the mainline updatability. So you've probably seen that maybe on your device you have web views updates, security updates. Now I think Bluetooth also is included. Now what we can do is we can keep adding more and more features without having to wait for the next version of Android. We can just do that in between. And obviously we're adding features rather than removing, so don't worry about AppCompat. We're not destroying you here. But the photo picker is using that feature, and that's why even though we added it in Android 13, we also backported it to Android 11 and 12. And that works with all the OEMs that use Google mobile services, except Go devices, obviously, because they're super restricted in terms of resources. But your usual OEM will have them if they use the Google mobile services. Okay, so before we deep dive into like proper code, because well, so far I just talked and just having some slides with text. One thing to keep in mind is whenever you're dealing with I/O, so whenever you're dealing with storage, keep in mind, as I mentioned, the memory card may not be available. You may not have enough storage. The device may just crash for whatever reason. You may not have permissions. And all of that is kind of resource heavy. So always make sure you do not run that code on your main thread. I know sometimes creating a thread is just annoying. That's why in Kotlin with coroutines it's super easy to do so. So please do not run things on the main thread. As an example, I think on my device, well, this one is the Pixel 7. I love it, by the way. I don't have a lot of pictures because I got it recently, but on my Pixel 6 device, within a year, I think I had more than 15,000 pictures. So if you're trying to load them or just trying to get all of them straight away from the main thread, I'm literally going to uninstall your app because you're just killing my performances. So keep in mind, of the main thread and with dispatcher.io in Kotlin with coroutines, super easy, you don't have to do the rest. And always make sure you try catch any possible errors. Again, the material, the hardware may fail, like an SD card in some cases. You may have not enough storage, you may not have the permission, so do not assume things will just run smoothly. That's, I think, an advice overall is not just on storage, but on storage specifically, there's a lot of constraints you have to think of. And when the work doesn't work, make sure you handle it well. And just do not crash or fail silently. Like literally, I came to a point where now I can reverse engineer just visually apps to know like, oh, they didn't handle well the try catch. That's why it's not working. The users will not forgive you for that. Okay, now let's move into how to add files on the different types of storages. I think that's just one of the most common use cases. Let's say you're adding a file that's really particular to your apps, like private, maybe has passwords, something that's just for you. So if you have to make any HTTP query, I mean, I love OKHTTP. A lot of you, I guess, love OKHTTP. Just do the job super well. And in this case, let's just imagine we have another function that do the OKHTTP calls and returns an input stream. What we will do, if we want to save the files just for our app, private, we don't want anyone else to have a look at them, we'll use the filesdir property, part of our context. After that, we just choose the location. I mean, we can create a subfolder, but in this case, I'm just going to have a config.json. And after that, I'll just need to copy the bytes from the input stream to the output stream. First thing to know is in Kotlin, I'm sorry for the Java developers. Whenever I try to write, it just takes way too much time for me. And who wants to write Java anyway? I'm joking. One thing you have to notice in Kotlin is if you use the .use extension function, it will close the stream automatically for you at the end of the callback. So rather than having any possible memory leaks or forgetting anything regarding your memory usage, and my colleague here, Ben, made a great talk on performance yesterday. So make sure to watch it if you haven't attended it yet. And any memory leaks that you do not close, any stream, any resources you do not close, will hit your performances, will hit your memory, and may literally close your app because you kept using and abusing the memory. So in this case, the .use handle that for you. You don't have to close the stream by yourself. Same thing there, our input stream, we use it, and after that, at the end of the callback, it would close. Same thing for our output stream. And in Kotlin, we have an amazing extension function, which is .copy_to. So I kept looking online, and people still do a while loop with like a buffer size, trying to copy the byte from one part to another. .copy_to just do that for you. So that's all you need to download a file, copy it to your internal storage, and voila, it works. All right, now let's go into like you're downloading a huge file. Probably your best movie in your favorite streaming app. I'm not naming any ones for obvious reasons. In this case, because it's kind of related to your app, it's not too private, but as I mentioned earlier, your internal storage is probably your most efficient storage. So by default, we look if we have enough space there, and we try to save the file there. If we don't have, we're looking for the external storage folder. And notice here that there is external files dirs with an S, because you may have a primary one and only one on Pixel devices, for example. But on Go devices, where you may have memory card, you may have more than one. So on the primary storage, on the primary volume, you may not have enough space, but that SD card that I paid a lot has a lot of storage for that. So have a look and make sure you always look at all the types of storage. And lastly, if you don't have enough storage, let's make sure we handle that properly. Here I'm just throwing an IO exception. Please just do not do that. Show at least a toast to your users. They will appreciate. And on Oreo onwards, if you want to make sure you have enough space and like that's guaranteed for you. I mean, again, nothing is guaranteed, always try catch. But if you want to have the best way to save space for you, you can call the storage manager, try to get an output stream from the file you're looking to save in. Here we're getting the file descriptor, and there is a method named allocate bytes. If it has enough space, it will succeed and not fail. And if it doesn't have enough space, it will try to clear the caches to make sure you have enough space for you. So obviously, given the operation is quite heavy, you should not call it every second. But see, even there is a way for Android to make sure like we will find space for you. We will make priority for you. So we have a lot of those methods. If it's critical for you to save big files whenever you're saving camera or you're streaming and saving at the same time, those methods will help you a lot, and make sure to use them. Okay, so we've seen so far how to add files on our internal storage, how to add on our internal or external storage, but again, it's really specific to our app. Now we'll take a use case where we want to save on the shared storage. So the user wants to save an image he just took from your app. The first thing to do is, up to Android 9, we need to ask for the right external storage permission. But remember, after that, we don't have to request it. So please stop requesting right external storage, please. Second thing, we'll use the environment.get external storage public directory. We're so verbose sometimes. To get the folder where you can save those images. And that will be the right location on the shared storage to save any type of images. Here we're choosing a name. Make sure that there is not already another file. Maybe you're overwriting, so have a look. And lastly, you know that sometimes, especially on older device, when you take a picture or when you save an image from somewhere else, you can't always find it in another app. So let's say I'm taking a picture, I'm applying a filter in Photo Gallery with an amazing filter app, and I'm trying to share it in my favorite social media app, but I don't always find it. That's because Media Store haven't found that file yet. So what it does is, I think up to Android 9, when it's charging on the right condition, it will try to scan for new files. But if you want to make sure the files you've added are visible to other apps, you can call Media Scanner to tell Media Store, hey, please scan this file, it's important, I've just added, do not forget it. And that being asynchronous, just make sure that you will have a callback. And in this case, after that, we'll have that URI. If you need the URI, you have it. If you do not need, no problems, but at least it will be visible to other apps. Okay, I still have a lot of slides, and I don't have a lot of time, so I have to go much faster now. All right. So far, I just show you how to add one file. Now, let's say you want to add multiple files on Media Store. Again, Media Store is being the content provider that scans all the shared storage. Media Store API, I didn't put all the code snippets here because it's a bit longer and I didn't want to make it too verbose, but it's more efficient, especially on Android 10, because on Android 11 onwards, because I mentioned earlier we have Fuse, which is a virtual file system, but it uses Media Stores underneath. So there is still a performance impact. If you're adding a lot of files, adding directly to Media Store is probably the best way to use performances. You can use the is-pending that I mentioned earlier, is-trashed, is-favorite. All of those are only available when you use Media Store API. And lastly, if you want to add files in batch, you can do that as well, while file APIs don't allow that. All right, now let's go into storage access framework. I should have rehearsed more. So when I mentioned earlier the document picker, I'm pretty sure you've already seen that UI. So whenever you're trying to select a file, that's what's coming up. We call that the document picker. And the API behind that regulates all of that is the storage access framework. You do not need permission to use it as a developer. It's just intents that you have to throw. You don't have to maintain the UI, and we know how UI can be painful to develop sometimes. Files can be modified and deleted from KitKat onwards. That's also a handy thing. We don't have to stick to our usual API or request wide permission for that. Whenever you use it, it will return a URI. So you can open an input stream or an output stream from it to consume or write content in it. And by default, URIs access are granted until your app is closed. If you want to keep it after, you have to persist that URI, and there is a method for that that I will show just a bit after. And if you want to be your own document provider, so being visible like Google Drive, there is a document provider class that you can implement. So let's say you have your own Locker, your own cloud gallery, you can expose it in this way. So to add it, don't try to create the intent by yourself, it's just painful, and we made the Jetpack ActivityX library for you. You just have to add the dependency. You register the activity result with the open document contract, which will return a URI, can be null or not, depending if the user has made a choice or not, and just consume that URI. And the way you use it is just by launching it with the MIME type you want. You can put an array of MIME types if you want, and in less than 5-6 lines of code, you have a file picker without any permission. That should be the case for every app to do so. One thing that I want to mention, I'm just going to back quickly to the slide on the document picker. So a lot of apps, and especially from a designer perspective, might say, yeah, but the UI doesn't integrate well with my thing. That's a fair comment. But the other part that you have to consider, especially if you're not the leader of your market, is any new user that will use your app has to learn how to select files from your app. Yes, the UI will be more or less the same, but it'll still be different. When you're using something without permission, first, the conversion rate is better because you don't have to expect failures. And the second part is they know that UI. In a way or another, they have found it in many other apps. So the learning curve for them is much easier. So consider that part. It's not just privacy friendly, it's good as a competitive advantage. Okay, let's go back. Yeah. When I mentioned earlier, if you want to persist access to a URI, you just have to call the content resolver with your URI and the flag to read or write in it. And after that, you'll just have access to it even after your app is closed. Or let's say with a work manager, you scheduled some backup eventually at some point, you will be able to access those files still afterwards. Complete failure to update that slide. I'm sorry. There is just no way to explain it. I think I put it somewhere else. And made sure to share my slides at least for the ones who are expecting something there. Okay, now photo picker. So that's something we've added in Android 13. Photo picker, I'm pretty sure you've seen some blog post, my blog post, that I shared last week or 2 weeks ago. And that's something I've been working for quite a long time. So document picker allows you to select any type of files, including image and videos. But for image and videos, the goal is not, at least for most users, is not to look at it through a file name, a size, when it has been added. Is really visual. Like we want to be able to just look at the image and select them, or even preview them, especially if you've been to a concert, all the videos look the same, but you want to find the right spot. That's where the photo picker kind of shine. It's really focused for that use case. Again, no permission, much better UX. You don't have to do that, and try to do it. It's really painful. I look at the code. You can set a max limit of images. So I think that's something we've seen with the document picker that some folks were frustrated with, is let's say you just want to add maximum 5 images or videos. You can't do that. Or let's say you have to let the user fail, and after that tell him, sorry, I couldn't take all of them. Please just select 5. Here you can limit that directly in the UI by a simple parameter. Backported to Android 11 and 12, and we will soon include cloud pictures, videos, and albums. Just by the way, photo picker include photos and videos. The name is shorter, but it's photos and videos. So if you have Google Photos, for example, all your cloud photos, even from a really long time ago, will be directly integrated within it, which is something that Android never offered before. And within that smooth UI, really integrated, you do not have to develop all of that, and it's just 5 lines of code. So make sure to add the last version. I've added a small bug by mistake. So that's why you need to make sure to get the 1.6.1. And similarly to what we saw earlier, we register that specific contract. You get a URI back, and you just have to select with image and video. If you want be differently, if you want just image, you can put image only. Video only, or if you want a specific MIME type like GIF files, you just need to do that. If you want multiple files, now I'm going super fast because I'm already late and I don't have a lot of time, you can just put a parameter there with pick multiple visual media, and same thing there, the limit will be respected by the photo picker, and you don't have to implement any of that UI. It's just 5 lines of code. Now the future of storage. Privacy and transparency. Expect users to be asking more questions, why you're asking that permission, why you're accessing those files. And we will work to make that more transparent for them. The other part, always choose permissionless APIs, whether it's photo picker, document picker, is just much easier, and we keep adding more and more features in them rather than on the usual java.io.file APIs. Lastly, prefer the URIs, even though file path can be super convenient sometimes. With cloud albums and pictures in the photo picker, for example, you won't have access to file paths. It's only through URIs. So make sure you upgrade or migrate your system to only use URIs. Recap. All right. We've seen how to choose the right storage. We've seen that we can stop requesting write external storage, always try catch and run operation of the main thread. Be conscious of asking permission, or even ask yourself, do you need to ask that permission? Prefer permissionless APIs like photo picker or the storage access framework. Prefer URIs instead of file path because of all what I mentioned. And privacy is not only user-friendly, it's also good for your app and for your business. Here's a quick QR code you can scan. It's just the documentation. Again, the video will be online. You can look at it afterwards. I'll let quick pictures, but again, it's just the documentation. Thank you. Can I have some question or no? Oh, sorry. I will be just outside. Thank you very much.